All right, Chapter 1 Summary. This chapter introduced the principle of the tuned circuit. The following is a summary of the major subject of the chapter. The effect of the frequencies inductor such that the increase of the frequency will cause the increase in inductive reactance. Remember that inductive reactance is 2 times pi times the frequency times the load. Or the induction. Therefore, the induction reactance directly relates to the frequency. The effect of frequency on the capacitor is such that the increase of the frequency will cause the decrease of the capacitive reactance. Remember that capacitive reactance is 1 over 2 times pi times the frequency times the capacitance. Therefore, the relationship of the capacitance reactance is frequency is the capacitive reactance vary inversely with the frequency. Resultant reactance is equal to inductive reactance minus inductive capacitance, or resultant reactance is equal to inductive capacitance minus inductive reactance, inductive capacitance and inductance reactance. Inductive reactance is usually plotted about above the reference line. Inductive capacitance below the reference line indicate inductance capacitance has the opposite effect of the current in respect of the voltage AC. Below the resistance of the capacitive reactance is larger than the inductive reactance. The series of circular pairs is capacitive. Above the resistance, the inductive reactance is larger than the inductive capacitance. The series circuit appears to have reactance. Inductive reactance is equal to the inductive capacitance, and the total impedance of the circuit is resistive. Resonant circuit is often called the tank circuit. Ability to take energy fed with the power source and alternate inductive capacity to produce the output with a source and continuous AC wave. Number of times set the events that occur per second and called the resonant frequency of the circuit. The actual frequency of the tank circuit will oscillate, determined by the formula. Resonant frequency is equal to 1 over 2 times pi times the square root of the inductance times the capacitance. In series of the LC circuit, impedance is a minimum, current is a maximum. Voltage is a variable. Voltage across the inductor and capacitor will equal but opposite phases of the resonancy. Above the resonancy acts inductively, and below the resonancy acts capacitively. And then in parallel circuit, the impedance maximum of the current is minimum. The current is the variable. The resonance of the two currents is 180 degrees out of phase with each other. Above the resonancy of the current is capacitive. Below resonancy of the axis occurs inductive. The merit or figure of merit, the circuit of the inductive reactance due to the resistance of the sense of the capacitor negligible law. The figure of merit becomes the equivalent of the merit of the coil. The merit is equal to the inductive reactance over the resistance bandwidth of the circuit range of the frequency between half power points. Limiting frequencies at those either side of the resonancy, which falls at 7 of the maximum value. The figure of merit is low, where you will have the wide band pass. Figure of merit is high, you will have a narrow band pass. Filter circuit consists of the combination of the capacitor's inductor resistor connected so that the filter either emits or prevents passage of certain band frequencies. A low pass filter passes low frequencies, attenuates high frequencies. High pass filter passes high frequencies, attenuates low frequencies. Band pass filter will permit certain bands of frequency to be passed. A band reject will reject certain bands of frequencies, pass all others. Safety precautions occur in certain series resonancy. Very high reactive voltage can appear across the inductor or capacitor. Care must be taken against possible shock hazards. And that was Chapter 1 summary.